Yeah, good morning, everybody. With some delay due to the bus transfer, we would like now to start our third workshop, introducing and disseminating the BIOMAT projects, especially to small and medium enterprises. We have some representatives of SMEs in presence today here, some others, up to 10 persons, are following this workshop by Teams, and maybe some more follow the streaming. So at the very beginning, I would like to make some smaller announcements concerning the organization of the workshop. We will have a lunch right after the workshop. If you want to, this will be served here in the Mensa of the Technical University of Wildau. It's a short way, about 5 minutes from here, and if you want to join for the lunch, then you should take one of the vouchers which are located on the last desk. That's all for the moment. I think we should start right now with the agenda, and as a first point I would like to leave the floor to Christian Dreyer from the Technical University of Wildau.
Yeah, ladies and gentlemen, it's a pleasure for me to welcome you here in our historical buildings here at the Technical University of Applied Science in Wildau. This is really historical ground. More than 100 years ago, they started here with the production of trains. The Schwarzkopf company was at that time one of the biggest train manufacturers within Europe, I think top 3 or 4, something like that. You can see also on this campus one of the train engines or trains itself. They are produced here over there, 50 meters. And this building used to be a old manufacturing hall, and well, we have now quite a very good, as Lutz Hartmann said, second use case here for the university. And the university itself is a university of applied science, as I already mentioned, with focus on engineering and also on economics. We have 2 faculties which are about 50-50 from the amount of people studying and teaching. We are a relatively small, tiny university with a little bit less than 5,000 students studying here. 450 employees and a little bit less than 100 professors. So it's a quite good ratio in my opinion. What can you study here from the engineering point of view? Of course, we have mechanical engineering, we have physical energy technologies, we have telematics, we have even a master course for bicycling. We have also a professorship for bicycling and bicycling traffic and so on. No joke. We have also biosystem technology and bioinformatics, so we are quite broad there, and the students have very good conditions because we have everything on this campus. We have also the student housings too here on this campus, and as you may have seen, we have also the S-Bahn station directly 20 meters next to the Mensa. This is probably the lowest distance in Germany from S-Bahn station to Mensa and also library. Okay, the old-fashioned heavy machinery is still here working at the end of the street, that direction. They are doing still the things they did 100 years ago. So parts for trains, so some wheels and so on, and also parts for ship engines, so drive shafts and such things which have the length of this room, and they are doing it with a precision of 10 micrometers, so which is quite impressive. So okay, but I will not cause too much delay, so I will then go to the point of the workshop and give it back to my colleague.
Yeah, thank you for this introduction, and I think now we should continue with the agenda, and this means that as a first point, the coordinator of the BIOMAT project, Santi, and will give an overview over the project and will introduce it, and also introduce also the testbed and the single entrance point. So I leave the floor to you. Maybe some technical remark also for future speakers. You should keep close to the laptop. Finally, use the microphone, but okay. This is the presenter.
Good morning, everyone. I'm Juliana Oliveira. I come from Senti, which is the coordinating entity of BIOMAT. And I'm here today in representation of the coordinating team to give you a brief introduction to the BIOMAT project, to the few of you who are not familiarized with our project. So BIOMAT, the open innovation testbed for nano-enabled bio-based polyurethane foams and composites. So as I'm sure that some of you that are part of this industrial sector are aware, more than 3/4 of the global consumption of polyurethane materials are used in furniture, in the automotive sector, mattresses, packaging, etc. However, the great majority of these products are petroleum-based and most likely lack one or more crucial and important functionalities such as chemical resistance, mechanical properties, antimicrobial properties, etc., etc. So it's particularly in that context that the BIOMAT project emerged in 2021 with the goal to establish an open innovation testbed, the BIOMAT-TB, which you'll hear a lot throughout this morning, with the goal to provide services to a wide range of European industries and SMEs, with the goal to motivate the uptake of innovation and in nano-enabled bio-based cellular products. Also with the emphasis on sustainability, circularity, use of renewable resources for the 5 target markets with the highest demand for these materials, which are the automotive sector, building and construction sectors, and furniture and bedding. So our project is, our project's consortium is built of 26 partners, which include SMEs, LEs, universities, research centers, and also a standardization body, which are all key partners in this polyurethane foams value chain. And the BIOMAT concept has the goal to take widely available and low-value residues, such as lean, cellulose nanocrystals, silica particles that are easily obtained from these renewable resources, and use them to produce nano and bio components, and then nano-enabled biomaterials to the production of prepregs and composites, biopolyurethane rigid foams, adhesives, and of course soft and rigid foams. And provide these materials, modify them with specific and appealing properties such as antimicrobial, hydrophobicity, etc. And then, of course, use these materials to include them and produce at the pilot scale products such as sandwich panels, insulation aerogels, seats, cushions, and other parts for the automotive sector, and chairs, mattresses for the furniture and bedding sectors. Of course, by the use of renewable resources, we also want to motivate their recycling and then, of course, be able to reintroduce them back into our value chain and through that reinforce, of course, sustainability and circularity within this sector. The materials that we are producing, we are including them in the development of relevant demonstrators for each of the sectors that are part of BIOMAT. And these demonstrators will then be used to test and validate their performance, of course, according to the requisites of each specific sector. So in the case of the automotive sector, we are developing seat cushions, headrests, and steering wheels. For the building sector, we are developing molded insulation panel and rigid biopolyurethane foams, used of course also for insulation. For the construction, we are developing lining for road tunnels and waterproofing. And for the furniture and bedding sectors, we are developing chairs, sofas, and mattresses. So we've been discussing about open innovation testbed, which might be a non-common concept for most of you. So what is an open innovation testbed? It's quite a recent concept that's been strongly motivated by the European Commission. And an open innovation testbed brings together a group of entities with a common goal and with a common theme. In the case of BIOMAT, it's the polyurethane sectors, with the goal to provide access to physical facilities, technologies, capabilities, and services to those representatives of the industry, such as SMEs, that might not have easy access to that capability for research and development. So here we aim to help the development, testing, and upscaling of nanotechnology and advanced materials in industrial environments. So the open access means that any interested user that might benefit from these advantages can have easy access to the facilities and the capabilities, very importantly, at fair conditions and pricing. Of course, regarding security, safety, and also intellectual property rights of the development in hands. Any user can actually take advantages of the open innovation testbed facilities and services. It can be an individual, it can be a team, or even an institution, as long as they are interested in the services that we have available to offer. So in this slide you have very quickly summarized all of the services and technologies that are available currently in BIOMAT-TB. It's quite a polyvalent catalog of services that aims to provide support in all aspects of product development, from lab scale up to pilot scale, and covering the entire value chain of the polyurethane. So from the raw materials, components, nanofillers, up to the production of the products. Actually, as you can see there, the catalog is divided into two main sections. So the technology transfer and the supporting services. Technology transfer more directed towards the pilot line production, and of course the supporting services more related to horizontal and business support services. So going into a bit more detail into the technology transfer. So BIOMAT currently has access to 12 pilot lines that are dedicated to the pilot scale production and recycling of both components, nanofillers, and foams. So starting with, of course, the production of biofoam precursors and additives, passing through the production of adhesives and FPR panels, the production of biofoams, both soft and rigid foams, and lastly, the pilot line that is dedicated to the development of chemical and chemoenzymatic foam recycling processes. Additionally, we also are able to provide supporting services, in this case, horizontal services that can be the product's characterization, so think chemical characterization, structural, mechanical characterizations of both components and foam products, the implementation of digital twin pilots and inline monitoring, and of course evaluation of nanosafety and toxicity of materials, as well as knowledge transfer services such as LCA and LCC studies, mentoring for fundraising, business plans and marketing, and also IP management rights. Besides all of these services, of course, we will go into further detail during today's agenda, and all of them are also available for your consultation, and the complete catalog of BIOMAT's services that you'll be able to find on our online website. So continuing, I'll pass the word on to my colleague Barbara, that will explain how you can have access to these services and technologies.
Hi, my name is Barbara, and I'm here representing the single entry point. Our BIOMAT-TB is operated through a single entry point. The single entry point is the common point of contact between the customer and our service providers, and is the one that is allowing the open access to our facilities and to the technical and supporting services at fair conditions and competitive prices. We have in our project an open tender. This open tender aims to validate and prove the concept of the BIOMAT-TB, and we do that by offering our services free of charge to selected applicants. In order to apply to our open tender, you need to submit a proposal during an open call. We will evaluate your proposal, see if it fits in our OITB, if your service is feasible, and the selected applicants will be receiving the services. After that, there's the execution of the services. When the proposal is selected, we sign an agreement with all of the details of the service, and after that, the service provider will begin the service execution. We aim to deliver the results within 6 months, but that will obviously depend on the service course, the type of the service, and the requirements of the service and of the customer. We have had already one open call that was open through January until March of 2023. The customers applied to one technology transfer service and to one supporting service. We received 9 proposals, 5 of which were approved to receive these services free of charge. And we received proposals from 7 different European countries and from various sectors of activity, from the furniture and embedding industries, building, automotive, and other multi-sector proposals. So we will have a second open call through the 31st, that will open on the 31st of July and go through until the 15th of September. So stay tuned for the open of that call. You can apply to the call by going to our web-based platform. Through through there you can register and apply, submit a proposal. And if you are interested, you can do it through this second open call that will be the last one that we have. And that's all from us. Thank you very much.
Yeah. Thank you for giving the introduction to the project and to the testbed and the single entrance point. And now we will jump into the second block of the agenda, so to say, and this means that we have in total 10 enterprises. Some of them are present here. Some of them are following the meeting via Teams. And they will now giving for their enterprise a brief introduction of their activities. And so we will start with Dr. Christian Battenberg from Clariant Plastics and Coatings. Okay, here we are, and yeah, the floor is yours.
Perfect. Thanks very much for the nice introduction. Good morning, everybody. I will introduce shortly, in some minutes, the company Clariant I'm working for. I'm Christian Battenberg, by education a chemist, and now focusing as global segment manager on thermoset applications, where especially flame retardants are used, and we as Clariant also are producing flame retardants. But let's have a short look. We are a global company located in, let's say, nearly everywhere in the world. By sales, we are in above 5 billion Swiss franc. So you can see we are a Switzerland-based company. We have 3 big business units focusing on totally different areas in the chemistry industry. 11,000 staff globally and several production sites for various products. Let's say why we are also interested in this project or cooperation is we are highly focusing on sustainability. We have clear targets to reduce greenhouse gas emissions to 2030. I think we are reporting all these sustainability topics already since many years, and therefore we are also listed in the Dow Jones Sustainability Index, as this topic is for us quite important, and we're really focusing on it. But yeah, let's perhaps jump more to the chemistry or to the different products that we are producing and the markets that we are serving. So I'm from the unit additives or absorbents and additives, and in the additive business we are focusing on different markets. One is the plastic market. They are producing additives for antioxidants, light stabilizers, so really for many different polymers and markets. I'm from the unit e-mobility and electronics. There is focused more on flame retardants for e-mobility, electronics, but also polyurethane foams, composites. And the third unit is coatings and additives, and they are also focusing more on special products like waxes, stabilizers for adhesives or for coatings, even flame retardants for coatings. So you see we have a quite broad field in the additive business that we are serving. Yeah, globally, for the additive business, we are about 900 people, have 4 technology centers. I'm based in Frankfurt at the Clariant Innovation Center. That's one of our global centers. And let's have perhaps a look where we are located. By history, we are mainly located in Europe, but also especially with focus on APAC, Greater China, and in general APAC, we are focusing here quite a lot, as there are also the highly increasing markets. For example, for e-mobility, this is also quite important market. But of course, we are also located in the US, so quite globally. And let's say the flame retardant business by history is located near Cologne, because there we have the big plants for flame retardants, but we are also just build a new plant in China for flame retardants. Yeah, let's perhaps focus a little bit on what we can offer and where we are supporting. Just one slide on e-mobility. There you see our different offerings. So for us, more the flame retardants, but yeah, here are really wide variants of different products. I will not go into detail, but we are serving really, for e-mobility, for example, totally different applications besides foams, other needs. So yeah, quite a lot, and yeah, too much to explain now. Yeah, let's perhaps have a look where I'm focusing on. What is my focus area, or also from my colleague, Florian Clausen, what are our focus areas? So we are focusing on thermoset resins. On one hand, you have resins to the left, like epoxy, unsaturated polyesters, and others. This can be for consumer electronics, like 5G circuits, flexible circuits, but also transportation, railway, trains. E-mobility, there are really many different, let's say, subclasses for thermosets that are of interest. Polyurethane foams are also more and more used here, or we see it more and more. And let's say for polyurethanes, the other applications where we are focusing on insulation, bedding furniture inside the car. So yeah, I think there's a nice fit to some things we have heard before. Yeah, that was a super short introduction. I think time-wise this should fit, and happy to discuss with you today.
Thank you very much. And just one remark to the participants following in Teams. So just to follow what is going on here in the lecture hall, you should make use of the streaming option we have offered, and only if you are going to present your slides, then we will do it via Teams. And now we will continue with Mr. Stefan Beetz from Weiß Technik. Das werden wir gleich sehen. No, das war, sorry for this. War ja eigentlich. Okay.
So, okay. So good morning. So Lutz was very strict, giving only 5 minutes for the introduction of a company. So I try to hurry and not to be boring. Don't get confused if you hear the name Weiß Technik, because we are part of a bigger company which is called Schunk. And Schunk basically is divided in two parts, which is the materials engineering parts and the machine part. So materials engineering, the original is coming from carbon and stuff like this, but we also do ceramics, and now we do quartz glasses and sinter metals as well. And we have the machine building part, and this is consisting of, example given, environmental simulation chambers and industrial ovens, but we also have some optical machines, example given, whoever has a glass or on his nose, it could be that this glass is manufactured by a machine coming from the company Optotec, which is part of Schunk. Talking about the environmental simulation and the industrial heating technology, so we do these chambers here, climate test chambers, we do the heat treatment, but we also do space simulation, and one of the most activities that we have right now is the battery testing aspect. So a lot of things are happening with regards to the battery manufacturing, and they need to be tested. So this is what we do as well. When we talk about the microwave stuff, and this is why I am here today, because we have one of our chambers sitting at the Fraunhofer IAP at the PUCO for, I think it's 10 years now. And so we had a kind of an evolution for this microwave, starting with a simple microwave chamber, then adding some facilities like a hybrid, so you can combine microwaves with hot air. And we also have a way of agitating stuff inside by rotational driving devices. We can also have a continuous system. And we do a specific system for disinfection, so it has nothing to do with, let's say, manufacturing, but we are disinfecting polyurethane foams. At least there is a connection to the polyurethane stuff we have heard of. And in the microwave business, there is a current trend that the people are trying to change from magnetrons to semiconductors. So using microelectronics instead of this vacuum stuff there is potentially giving an advantage with regards to the lifetime of the equipment. But I would say this is still in the starting phase to get industrialized. Okay, Lutz also asked to say something about how we are thinking about collaborations and R&D, and I give some examples here of what we have participated in the last 5 years, I would say. So you see there is an internal project with the KIT in Karlsruhe. Then we participated on a European funded project, Tomocon, which I would say it's a similar setup as here. A lot of universities are participating, lots of PhDs around in there. Then we are also participating on German-funded projects, and also together with the Fraunhofer here, we have some AIF, IGF projects where we are an industrial partner in that sector here. Good. So what is it? So innovation is not appearing from somewhere. You need to work on it. You cannot sit two people in a room and say, in 3 days I have an innovation. So it's a longer process in here. The interesting thing is, we have the machine know-how, but you have the process know-how. So only together we can work and get something out, this project here. And we are happy to support as much as we can. And I wish you success in the project. Thank you.
Yeah. Thank you very much for this very interesting presentation. And now we will have the first speaker who will participate via Teams. This is Mr. Trimbos from Sudal. Yeah, you are present here, and I would like to ask you now to share your presentation and to hold it. Mr. Trimbos?
Yes.
Okay, we can hear you already, and I would like now to ask you to share your presentation so that we can... Yes, there's something already. Yeah. Maybe you could still use a full screen option to get rid of the Teams frame.
What option?
Yeah, a full screen, but we see your presentation, but with the Teams frame still around it. Oh.
Okay.
This is...
I will try again to... Is it now better?
No, it's basically the same. But maybe we can, I think it's visible, or we can keep it like it is now. So just start your presentation, so we do it like this, it will work.
Okay. So Sudal is a family business founded in 1966 by Vic Sweat, and still 100% family owned. Typical products that Sudal makes sealants, adhesives, and polyurethane foams in the can. Sudal is working more and more on getting the brand name more known, and you may be familiar with the cycling team, and know Sudal from the Tour de France, for example. Here's some figures. We have 25 production sites, 75 business offices in 140 countries, we are represented. We made a turnover of 1.3 billion in 2022, and yeah, here's some figures. You can see the PU foam cans. We are the largest producer of PU foam cans in the world, with last year 105 million cans. So the PU foams are round about 1/3 of the total production of Soudal. And if you look at the foams, 97% is one component foam, which is the canister foams known from the building markets. And 3% is two component polyurethane foam systems. And we started that since 2013, and I am the R&D team leader for those systems. So we're actually a system house. We have the chemistry that we develop in our R&D. We have own engineering. We make some own machines to inject foams and spray foams, and we manufacture the systems. We deliver to the construction section and also to industry, and mostly by IBCs or drums. So always as a package of two components, being a polyol resin blend and an isocyanate type. We also have own machinery, as you can see here, for low pressure disposing of polyurethane foam. Also systems that don't need any machine are the canisters that are on pressure, and you can use with a hose and a gun that mixes the two components together. These are some examples where we are in the construction is mostly for spray foams, where floors, walls, ceilings and roofs can be seamlessly insulated by polyurethane foam. We are in the cooling appliances, where, for example, these cooling counters can be made by injecting polyurethane foam systems in voids to be filled. Reefer reparation. Reefers are often used, and when they are damaged, they need to be repaired, and besides the steel facing, also the foam has to be filled again in the space to get a good insulation. And window profile insulation is something we are getting more and more into to get better insulating window frames. Oh yeah, prefabricated houses is something I forgot. So we are in several sectors selling these two component foaming systems, and we are of course looking to get more biomaterials into these systems, and that's why we joined this workshop. Thank you for the attention.
Yeah, thank you very much for this interesting presentation, and once we have the Teams line working, we should make use of it, of course, and we should continue with Mr. Utong from Intresmat. I hope I pronounced it properly. Ah, yeah. Hello. But Now you should still share your slides, please.
Do I use my slides or?
Yeah.
I can share a screen if you want.
You should, yeah,
Yep.
share the slides. Actually, in the moment we can see you, but not the presentation.
Well, no, I'm just launching.
Yeah, perfect. Okay, now we see it, and you could start.
Okay, perfect. Nice to have this opportunity to show what we are doing at Indrusmat. Indrusmat is a company that is refining the thermal envelope materials of buildings towards a more sustainable and efficient construction industry. We are based in Spain, Barcelona, also in the Netherlands, in Helen. And we have been supported by the European Commission, the regional governments of Netherlands, Catalonia, also Spain. So we are quite a public fund company. And the headquarters are located in Spain. We have an international office in Limburg, in Camelot campus. And our business is related to the polyurethane, bio-polyurethane formulations. This is where we are specialists. So we have a pilot plant where we produce one commercial product, I will show you later. And we have also several infrastructures for producing and prototyping new products. We have a highly qualified team. We are more or less 9 people to 10 in the company. We have also some companies that have been asked to go to develop materials, technology, and also products into the market, as well as customers to get this business more traction. So what we are doing is we are disrupting the polyurethane industry. We are a specialist on bio-based formulations, so we do material development for sustainable materials with advanced properties. We also design new products, like for example, window frames, which is our commercial product. And we have also designed some manufacturing and recycling technologies that we are, let's say, scaling up. So we use mostly natural oils as bio-based raw materials for our foams. So with these foams, we can work in 2 different densities: high density for window frames and low density for different kind of foams that I will show you in the next slides. So more or less, we are addressing 100% of the thermal envelope of buildings for insulation of walls, roof, floor, and also windows and doors. The first commercial product we have is a new type of window frame. So we make also windows here at our factory. And the thermal performance of these window frames, as you can imagine, is very, very, very high. Also, the acoustic performance is one of the best, or probably the best in the market. We have now the CE marking of this product. And the durability also of the material is an inert material, so it takes a lot of time to get the rating. And sustainability because of the use of bio-based raw materials, as well as a low energy manufacturing process. The circular design of our product, of this commercial product that we have, is related to the use of just one material. We don't use a combination of materials, so this is the most similar frame similar to wooden frames, but with a material that is inert. Insulation foams, the conductivity of the insulation, bio-based insulation foams, they are ranging from 0.026 to 0.080, depending on the density, on the product also. The bio-based content, nowadays we are reaching 65 to 75% of bio-based content. The carbon footprint is quite low. Introducing these bio-based materials, we can work in different ranges for insulation foams, and the durability is estimated at more than 50 years. So what about the insulation foams? We are developing and prototyping some foams for injection foaming, for spray foaming. We are also collaborating with one company in order to produce the first sandwich panels made of bio-based foam. And also with another company, we are also working in the development of ethics insulation. Instead of using EPS or rock wool, so we can use this material that is obviously with higher performance in the market. We have also a new kind of foam. Well, it's not the insulating the best value proposition, which is it's a porous foam that allows to grow plants and on top of the foam. So it retains the water and the plants can grow. It's a new type of insulating green wall that consists on 2 layers of polyurethane. One of them is porous and the other one is insulating. We are involved in 7 European projects. 6 of them have already started. Open innovation testbed for testing envelope materials. So we are familiar with this kind of project. We are also working in Surpass for a new reprocessing technology for polyurethane waste. And the rest of the projects are more focusing on the development of this kind of materials, spray foaming, sandwich panel, ethics panel, and also a new kind of facade made with a mold panel, which is currently on development. The circular approach for biopolyurethane, we focus on the natural oil sources because these are the ones that make possible to reach higher bio-based content. Despite they are not it is also a large-scale production of these materials and increasing every day. The intention is to avoid the use of fossil-based materials.
Mr. Otong,
yeah,
can we briefly interrupt? We have a small problem with the transmission here of your presentation to the screen. So just give us 1 minute to solve it. Presently we don't see your slides, so we just wait 1 minute.
You didn't see any slide?
Technik abschalten.
Do you want me to share again?
I will inform you, we just have to solve this problem.
No, this one should.
This switches off.
Yeah, it should switch
off.
It's not switching off.
So yeah, does not.
No, it's not switching off. We can turn it off and or on. It's not doing anything. I think so because they are both. Yeah. Okay.
The PC is working, yeah. But also it was interrupted from time to time.
So now this one is because they may have an automatic shutdown after a few hours.
This will happen again and again? Or?
I don't know if it has a timer. If it does, it will happen again, yeah. This is left.
This is left and this is right.
Do you want me to stop sharing and try again?
Okay, no.
Which was the last slide?
Yes, now you should continue, yes.
Did you see all the slides or?
Yes, now we see it again.
I'm just wondering where you lost my
Just speaking. Yeah, now you could continue. Sorry for this, but
Yeah,
it
but did you
became.
see this slide or not?
We see it now. You could continue.
No, but before, I'm wondering which slides you didn't see.
This is the last one, so we are at the right position now.
Okay, so I was telling about the circular approach of biopolyurethane. We are approaching the natural oils market that can come from natural crops, from the food industry oil waste, from domestic oil waste or seaweed oil. And the approach is to reduce or eliminate the use of fossil-based materials, combining also the recycling of mechanical recycling and chemical recycling in order to reuse as much as possible to promote the circular economy. What are our challenges? We must improve several bio-PUR properties: stiffness, temperature resistance, and fire retardancy. These are the three main topics that we need to improve in our material. And for window frames, especially also for insulation foams. And this is more or less that the topics that we should discuss with the project or whatever in order to have assistance on this. And that's all. So thank you so much. And I return the connection.
Yeah, thank you for your presentation, which I think fits very well to the focus of BIOMAT. And we should now continue with the presentation of Euros BIOMA given by Mr. Silva. So sorry again for the technical problems, but I hope that we will continue with more stable circumstances now. Yeah, hello, we can see you, and now you could share your slides.
Just a minute. I think you are seeing the presentation now.
Yes, we see it. Yeah.
Good morning to all. My name is Filipe Silva. I'm currently the product manager for Eurospuma. Eurospuma is a Portuguese family company that was born in 1965 from the founder José Moraes. And we are among the pioneers of production in foam and non-oven in Portugal. We are well known about our innovating products. Our foams are well known from the different kind of technical aspects they give. We have different kind of products that we incorporate different technologies like graphene or copper or titanium. So our foams are mainly used on the bedding industry. But we are also partnership with others like automotive. This is our factory in Portugal near Oporto area. It's in Espinho land, and like I said, we were born in 1965. Since then, we are evolving our production and our facilities to be successful in our industry. In 2006, we made a great partnership with a US-based company. It's Peterson. And since then, we launched in Europe a lot of new type of foams. And in 2021, we were ISO 9001 certificate. Regarding the company, like I said, it's located in Portugal, and currently we sell mainly in Europe. We sell also in other countries outside Europe, but mainly in Europe. So if you don't know us, probably you have something with our foam inside your house. Regarding we also want to take care of this problem. We try to pursue it all the agenda from United Nations to be more sustainable, and also in our portfolio we have natural-based oil solutions to try to promote this new kind of products with the benefits of this, with low CO2 emissions. Like I said, we partnership with recently in the last years with the Urban Rec project, where we are able to do pilot batches of foam with recycled content, higher recycled content, and we reuse all our scrap foams and do a new product like the composite products to try to be have less wastes of products to the environment. Our focus is to increase this offer in the next few years. So the bio-based solution for us is very important to have newer and at the same or even lower cost of the current solution to increase the bio content of our products. Regarding the people that work with us, we are like a medium and big company. We have like 2,000 people working here. So we are like a small and medium enterprise for some. And regarding the environment, we are, like I said before, ISO 40,000 approved, and in Portugal, Ponto Verde certified. We also comply with the VESO directive, like we have to. Regarding the community, regarding us, we are very well known in the area because we try to help our institutions and associations. So we have a lot of partnership between us and other institutions in Portugal. So Eurospuma, if you need to choose the right product, will be simply with your help. So if you need any help, please let us know. Thank you for your attention.
Yeah, thank you for your presentation, and we should continue also online with Dr. Yoncharai from the Vita Group.
Good morning, can you hear me well?
Yes, we can hear you. Also, we can see you now, and so you are asked to share your slides.
Yes.
And now we see them, yes, exactly.
There you go.
Maybe just one moment. I would like to propose that we continue with the online presentations to avoid useless switching. So I propose that after this presentation, we continue with Mr. Hildebrand from Polystal and Ms. Bergmann-Herzog from Leoni, and then only one time we switch back to speakers who are present here in the lecture hall. But now the floor is yours.
Okay, yeah, thank you very much for well, the opportunity to present my company, the Vito Group, to you today. So I'm Thomas Joncherey. I joined the company only recently as an innovation manager in Breda, in the Netherlands. And before I worked for 15 years for Huntsman, which is also involved in polyurethane markets. So as you can see on this map, the Vito Group has a very strong presence in Europe, in 13 countries, with 35 different sites. And the core expertise of the Vito Group is into flexible polyurethane foams, both the production of these foams, but also the conversion into different semi-finished products, such as sheets or rolls. We have two divisions, the comfort division and also the technical foam division. So the group is about 3,000 employees in total, and we sell polyurethane foam products all over the world, so not only in Europe, but also in the US and in Asia. So these are a few reasons why polyurethane foams are very attractive products and why they've had so much commercial success over the years. So they are very lightweight materials, so they are easily transportable. They are extremely cost effective and also scalable. You can control very well their porosity with open or closed cells. Also controlling the density that will also influence their porosity. They are very versatile products in terms of their properties. So, for instance, mechanical, acoustics. But they are also they can also be made from a variety of raw materials, including bio-based building blocks. And also they are fully recyclable with a number of recycling techniques which are being developed by a number of companies and which will be exploited more and more in the coming years. So because of all these very nice properties, that's why we are able to serve a number of different applications in the Vito Group. And here we've listed a few. For instance, automotive is a very big market for us, with, for instance, headliners products. Also aviation, building and construction with sealing foams. Also industrial applications, everything related to filtration, also the production of ceramic filters for the filtration industry. A number of products for the flooring business, especially rebounded foams, and also hygiene, rail, and our biggest actually market is comfort, both for bedding and furniture. Regarding sustainability, this is a very key parameter that we take into account when we develop new products, foam products within the Vito Group. And here we've listed a few of recent, let's say, products which were launched with very good sustainability properties. So, for instance, Origin foams are a range of foams which are made from bio-based polyols, such as castor oil. We have a Orbis range of foams which is made from polyols which have been recycled. Also, we have a Novus range which is about rebonded foam. So here we collect scrap foam from production, and we grind it, and we bind it back together under compression with a binder, and these products are used mainly for the flooring industry. And we also have an Exor foam range of products, which is used for applications where you need low emissions, for instance, in the automotive industry. So thanks to all these new products that have been launched in the last few years, then the Vito Group has received a number of awards and recognitions, which you can see on that slide. Now, obviously, the idea is not to stop here at all. Is in terms of sustainability and innovation, we will continue to reduce our scope 1, 2, and 3 emissions in the coming years and decades, and also to minimize the carbon footprint of our products. So this is it from my side. It was a quite short overview of the group, but thank you very much for your attention.
Yeah, thank you also from our side for your presentation. And as announced before, I propose now to continue with Mr. Hildebrand from Polystal, so that we keep to the online presentations. And
yeah, hi everyone.
Hello. But we cannot yet see you.
One moment.
Ah, yeah.
Okay, maybe you can see.
Now we see your slides.
It's okay?
Yeah, you should start with the presentation mode. We see now the PowerPoint screen.
I can just see my screen. Maybe you can see it too.
We see it too, but you should maybe start the presentation. This was F5. Or just there's one symbol indicating a screen which can be pulled down and.
Don't understand the problem.
Maybe just press F5 on your computer. Just press F5, the functional key, F5.
Yeah, that's what I did, but can you see something beside my my presentation?
No, we see just the PowerPoint screen.
I don't understand really.
Yeah, then maybe we propose to.
One moment, I try to take the PDF one. So. Is it now okay?
No, we see nothing. Just share once again.
What's the problem?
Ja. Now it's perfect. Now we could start.
Okay.
Thank you.
Yeah, sorry for that. I'm Björn Hildebrand. I'm the technical director of the Polystal company in Hallensleben near Magdeburg in Germany. We are producing high-performance composite materials, FRP, mainly made of glass and aramide fibers and thermoset plastics. Our main business is currently duct rods and cable laying equipment and fiber optical cable equipment besides the strength elements that gives the strength to the optical fibers in a cable. And last but not least, we do several million raw rods for car antennas for the small cars that is on the roof of the car in the back. We were founded 1993 as a bio spin-off in Haldensleben, and since 2007 we are a member of the WIMS group in Germany. We have a huge capacity of in kilometers of our material, around 300,000 kilometers per year. We are 30 employees in the moment, and we sell to all over Europe and a little bit in North or South America. Our USP, we have a sophisticated production technology by outstanding material properties comparing to our competitors in China, for instance. Our main business is the service quality and the customer orientation, and we also can do in-house research and development. Our material combines optimal density of reinforcement fibers. We achieve around 80% by weight, and have a surface of our material that gives a very good process capability to the cable manufacturer or for the manufacturers of cable laying equipment. Shortly, the main material properties of our glass material and of our aramide material, we use aramide by Tegin. Small overview to our technology. We use the endless reinforced fibers impregnated by resin and wrap a filament around. After that, we use curing of temperature or UV as well. And afterwards, we can wind it on spools or cut it directly in pieces. We also can make a thermoplastic upjacketing for the material of the requirement of the customer. We can also sheet with a swellable coating, and we can make steel strands or wires with our equipment watertight. We can also embed elements in the surface or in the middle of our FRP material, like copper wires, cables, or optical fibers, and have special profiles for instance, sports or agriculture, or also for concrete armoring. Yeah, our production is high flexible. It's certified by ISO 9000 and ISO 50001. Our standard delivery length of one diameter is between 25,000 and 50,000 meters per one reel. And for our main customers, we have a permanent stock of all types they want of around 500 kilometers. Yeah, a small overview to our main European customers, mainly cable manufacturer. And that was my, from my side, our short presentation of Polystahl. Thank you.
Yeah, thank you very much. And as a last online speaker, we have still Ms. Bergmann-Herzog from Leoni Bordnetzsysteme. And I think you do not have a presentation, but yes, maybe could introduce yourself briefly and could describe what is your relation to the workshop today and your focus in terms of polyurethanes.
Yeah, of course. Hello to all from my side. Yeah, sorry that I have no prepared presentation, but I got the invitation to spontaneously for preparing one. So yeah, I would say in short and pregnant words, my name is Maria Bergmann-Herzog, and I have been working for Leoni and special for the wiring system division in the product development. The Leoni wiring system division develops and produced cable harnesses for automotive suppliers, passengers, cars, commercial vehicles with integrated wiring systems for high and low voltages. For example, battery solutions, power distributions, and special connectors. Leoni has a global manufacturing footprint in 46 plants in 17 countries, with head resistance in Nuremberg and engineering in Kitzingen. And I think overall we are around about 100,000 employees in the wiring system division. I'm responsible for the development of the harness attached parts in the RHQ phase, out of plastic, foam, and metal parts. PU foam topics, what we have are grommets and pass-throughs to reach water tightness and separate or isolate dry room in the car from the wet side. That means, yeah, the outer side of the car. And additional, we have some other foam solutions to get a more stable harness in local areas, to get the really flexible cables in the critical car areas under control, and to guarantee a safe assembling process in the car. Yeah, so I think recycling and biopolyurethane is, of course, a really interesting topic for us to become more environment friendly with our products. Okay, yeah, so thank you for your attention, and yeah, that was from my side.
Yeah, thank you very much. And now we will continue with the next presentation given by Mr. König from Motzner Kunststoff and Gummiverarbeitung. So the floor is yours.
Okay,
just
thank
take
you.
the microphone. Yeah, this is the center.
Okay. Over there?
Close to the laptop.
Which one? This is here. Okay, hello everybody. My name is Matthias König. I'm the CEO of the Motzner Kunststoff und Gummiverarbeitung GmbH. It's a long word. Yeah, we are an IATF certified company. That means we are certified for automotive business. We are focusing on injection molding since 1931, so it's a long tradition in processing rubber and plastics. Yeah, so that means we are, for our customers, we are focused on producing parts out of rubber and plastics, and also assembly groups. We are located in 25 kilometers far from Berlin in the south, so not far from here. As I mentioned, we are since 1931, Hermann Buchholz started with production of plastic parts with injection molding machines. In 1980, we started with rubber processing. So that means also since many years we are focused on rubber parts. Our company is not that big. We are around 65 employees. We have 3 business fields. The biggest one is the production of rubber parts, in especially seals, seals with a specialty on dynamic application. So in different size, our biggest seals can go up to 1.6 meter, and our smallest one is like 5 grams. So that means from small to big, we are able to produce seals in different shapes and different colors. Our second field is two-component injection molding. I will say a few words about this in the next slides, and this third field is plastic parts. We are equipped with an own tool shop, so that means we use our own tool shop for maintenance and also for producing injection molding tools, and also for outside business. We have a huge department for quality control, for finishing, and also for assembly steps. Here you have a short overview about our biggest field, high performance seals. They are mainly used in phase seals application, for dynamic and also for static applications. Our biggest seals, 1.6 meters, are used in big mining trucks. You can see in one of the pictures. Also for drilling equipment in mining, for in bulldozers, and also for devices in agriculture. Our second field is the two-component injection molding. Here really with a specialty to process in one injection step thermoplastic and elastomer. Of course, we are also able to combine thermoplastic and thermoplastic elastomer, and also two thermoplastic in one injection step. The parts are a bit smaller. Mainly to say here, all the projects are focused on cost reduction and to give a part more functional advantages. So this is really a specialty from us. Another big business is also we are producing components for the electrical industry. We are producing a lot of parts for capacitors, switches, connection elements, insulators, such kind of parts. And in the last couple of years, this field is very, becoming more and more popular, especially with the new fields, electromobilities and renewable energy. In those kind of industries, we are having many business at the moment. Of course, on our sites, we have an own tool shop with everything what you need for producing injection molding tools. Also for following the quality on our parts, on our rubber and plastic parts, we have all the necessary equipment in our sites. And as I mentioned, we have a finishing department where we are able to control, to finish, and also to assembly parts with all the equipment which is needed. My last slide give you a short overview. Since long time we doing projects with different institutes. We are using them to get new ideas, new directions we can follow, which by ourselves in terms of processing, new material, new processes we can implement, and also new ideas we can offer to our customers. And from my point of view, we are a strong partner for all of them, and we are open also for new projects. Thank you very much.
Thank you for your interesting presentation. And now, as the last speaker in this section, we still have Dr. Kalk from Leunaharze. So the floor is yours, the presenter.
Yep, thank you. Hello, everybody. My name is Klaus-Peter Kalk. I'm the head of operation from the Leunaharze GmbH. We are a raw material producer, and we support the project with some products from us. The Leunaharze GmbH is part of the chemical site Leuna. You see the red cycle, there we are located. The Leuna site is the biggest chemical park in Europe, with around about 13 square kilometers space. You see in front the refinery from Total, the biggest part of the chemical park. The Leuna Harze GmbH is a private owned company. The epoxy resins in Leuna started in the 60s, and the Leuna Harze GmbH is founded in 1995 after the reunification as a management buy-in, buy-out, and the capacity at this site at this time was around about 4,500 tons of liquid epoxy resins. And now you see we are a little bit bigger. At this time we have developed our production capacity over the time with an investment from around about 415 million euro to around about 78,000 tons of BLRs. Epilox is our trademark, and the BLRs are the raw material for other types of resins, modified resins, waterborne resins. And this is a little bit about the development of the company. We have built a lot of production plants, and we are backward integrated in as the biggest producer of bisphenol F. It's a special bisphenol as a raw material for epoxy resins. The main raw material is bisphenol A. Epilox reactive diluents are a special part of epoxy resins coming from aliphatic polyols, and is also a part of the modifying from this from our products. We have also built a hardener production, because the epoxy resins only are not used in the application. You have also have every time a second component means hardener. This is a hardener plant, and our part is also back integrated in the epichlorohydrin. And our epichlorohydrin is based on glycerin, and this is a bio-based coming from the diesel production, and give us the opportunity to lower the carbon monoxide footprint of our products and roughly of overall products around about 20%. We are certified as EMAS, and also our products are REACH registered. And the main business where we're in is the injection for the rotor blades of the windmills. So you see the Leuna Harze GmbH in total at the moment. We have some space to develop the company in the next time. Thank you for your attention.
Yeah, thank you for your presentation. And I think we have now finished the introduction of the enterprises joining the workshop. So at this point, I would like to thank again all the speakers, both being present here, but also those who joined online the workshop. And now we will continue with the presentation of the pilot lines and the services which have been developed in the BIOMAT project so far, and which will be offered also to enterprises via the testbed, which has been introduced at the beginning of the workshop. And to start with, I would like to ask Letizia Verdolotti she is coming from National Research Council of Italy and will now introduce their pilot line.
Hello everybody, hello to online community. This is Letizia Verdolotti from National Research Council. Briefly, I want to introduce my institution. The CNR is the first research center of Italy, and in particular, my institute is the Institute for Polymers, Composite and Biomaterials, located in several parts of Italy. In particular, my location is in Naples, close to the sea and the volcano. Okay, due to the fact that our institute is a research center, we have in our institute several competences, several expertise, due to the fact that we have engineering, biologists, chemistry, designer, and so on. For this reason, we are competent in polymer chemistry, process technology, tissue engineering, and so on. Integrating these competencies is possible to answer to several societal challenges in several sectors: energy, transport, health, packaging, and so on. So, now I want to introduce the pilot that we developed within the BIOMAT project. In particular, in this slide, we report a schematization of our plant. Is very easy plant for the production of rigid polyurethane foam panels. In particular, we have a control panel to manage all the parts of the pilot. We have a system of pump connected directly with the tanks of component A, polyol with additives and isocyanate. We have a mixing unit in which we have a chamber and a mixer, and hopper to fill powders and a mold. This mold is possible to modulate.
But the microphone is on mute, so we can't hear anything.
I can restart. Okay. Now, work? Can you hear me?
Yes, now I can.
Perfect.
Thank you.
Yes.
Okay, work. Perfect. Hello again to the online community. This is Letizia Verdolotti from National Research Council. Very briefly, my institute is the Institute for Polymers, Composite and Biomaterials of National Research Council. The National Research Council is the first research center of Italy, and my institute is located in several parts of Italy. In particular, my city is in Naples. The organization of my institute, we have several competence in polymer chemistry, hybrid, nanocomposite, process technology, and so on. By integrating all these competencies, it's possible to participate and to answer to several societal challenges in several sectors: energy, buildings, heritage, health, and so on. So now I introduce the pilot that we developed within the BIOMAT project. This is a very simple equipment constituted by a control panel that manage all the parts of the pilot plants. In the pilot, there is pump systems connected directly with the component A, polyols with additive and isocyanate, a mixing chamber, mixing unit constituted by a mixer and a chamber and a hopper. A hopper directly connected with the mixing unit, in which it's possible to charge to upload fillers. And finally, we have an open mold that is possible to modulate until to 1 cubic meter. So now I want to show you how our pilot plant works. In particular, it's possible to pump component A, previous, of course, prepared, by using the pump system and by controlling the volume with the control panel in the mixing chamber. Subsequently, we add the filler by using the hopper, pre-weighted the filler, and after we defined the time by using the control panel, and there is the mixing stage in which polyol and polyol component A and filler are mixed. Subsequently, through the system, the pump system, it's possible to add isocyanate. Also in this case, by control the volume with the control panel, and all the components present within the mixing chamber is mixed in a predefined time. Subsequently, all the materials is poured within the mold. So, with this technology, we are able to produce rigid and semi-rigid polyurethane foams, panels, of course, and cube materials. And the peculiarity of this pilot line is related to the possibility to prepare composite polyurethane foams due to the fact that we are able to add fillers until to 14% And of course, with this technology and with know-how on the production and formulation of bio-based rigid polyurethane foams, we are able to produce materials with high mechanical properties with respect to conventional ones, good thermal stability, low thermal conductivity. So, of course, with the same technology, it's possible to produce materials, foam materials with other relevant applications, furniture, automotive, transport, design, and so on. And I want to thank you, all of you.
Yeah. Thank you for your presentation, and we will continue with Professor Sergei Grischuk from the University for Applied Science in Kaiserslautern.
Hello everybody, I would like to give a short overview of technical service related to the soft form formulations for furniture and bedding applications. Regarding the expertise in the BIOMAT project, there are 3 working groups involved of 3 professors, and we are providing expertise in the field of organic synthesis, polymer chemistry, polymer analytics, but also textile engineering, and as you can see on this slide, We are also very oriented to the innovative materials, for example, wheat reamers and several strategies related to the hybridization of the materials. By brief description of our technical service, in focus we have two main options, the development and upscaling of the completely new bio-based soft form formulations, but we are also able to test just alternative materials depending on the interest of industrial customers, very often in the field of additives or by replacement of polyols, isocyanates. We can cover all of this. Of course, I didn't include it in the list, but our pilot line is designed also to be able for producing of rigid polyurethane forms, as well as we can develop the casting formulations for the polyurethanes. At our facility, we are also determining the first parameters of the developed forms listed here. They're very crucial for technology transfer, the forming parameters. And then we also test some compression values and in case of viscoelastic forms, viscoelastic appearance. But we also have horizontal services in the test bed, being is an add-on for us, providing much more. What is important for the industrial partners, that using our pilot line, we can define the processing window for certain form formulation and optimize the process parameters oriented to the classical slab stock form production. And of course, finally, we transfer our protocols for the related processing to the partners or to the customers. Here, just the main parts of the pilot line. You can see here the production part. We also have a cutting device, sealed and equipped with vacuum suction system to collect the dust. So this dust we can also reuse in the chemical recycling processes. And on site, we do have the form qualification systems established in polyurethane form industry, namely BIOMAT, in order to check the forming parameters and purine kinetics, and also for viscoelastic forms, ResiMat, to get the viscoelastic performance. Of course, we have also in our facility other testing possibilities with universal testing machines for mechanical properties, thermal analysis, spectral analysis, chromatography, and something more. Here, just briefly, regarding the main part of the pilot line, the production part, the main characteristic, we have 90 independent metering lines which can be operated in both continuous and discontinuous modes. With these main characteristics is average shot volumes of 5 kg per batch, and the nominal output in the range up to 15 kg per minute. For special applications, we can also achieve 25 kg per minute. And the continuous production speed we can run at least up to 10 kg per minute. Some additional informations, we designed our line with the maximal metering speed of the basis polyol up to 15 liter per minute. And regarding the viscosity for isocyanate part up to 800 millipascal seconds, and for polyol side up to 15,000. So here I have a short video if it's work. Just to give you a better impression about the production part of the pilot line. As you could see, we have some more flexibility in our pilot line, including also CO2 forming technology is add-on to common external blowing or internal chemical blowing. And sorry. Last but not least, I have to stress also a few major aspects regarding the main products and characteristics. You see, in this project we are oriented on the development of soft foam formulations for furniture and bedding applications. Here are the demonstrators selected within the project. And regarding the performance, I have to stress that we have semi-automated operation of the pilot line for development of formulations for soft forms according to the requirements of customers and their specifications, and of course also the characteristics which should be provided according to the requirements for targeted application. Regarding the sustainability, we realize at the moment a bio-based content up to 75 weight%. We don't lose much materials, and we can optimize the processing cycles because of very compact design of the pilot line, and of course use of sustainable beneficial nanofillers allows us develop formulations with required performance but reduced weight. Thank you very much for your attention.
Yeah, thank you for your interesting presentation. Not LDF. And we will continue with Dario Matang from University Castilla-La Mancha, close to Madrid, I think. Here's the presenters.
This one
the left one is forward, right is backward, left is forward.
Okay, good morning everyone. My name is Dario Cantero and I am the representative of the University of Castilla-La Mancha, who is going to talk about our pilot plan based on the insulation aerogel panel production through freeze drying. Talking a little bit about the UCLM, the research staff involved in this project is part of the Department of Chemical Engineering of the University of Castilla-La Mancha. In the fields of conventional and electrochemical catalysis, this team has some experience in alcohols reforming, water gas sieve and Fischer drops, among others. So this profile allows the team to face some challenges, such as the development of new synthesis routes for carbon and carbon nanostructure materials and other inorganic materials, and the design, simulation, scale-up, and optimization of different chemical processes. Our pilot plan is able to go from 0.36 square meters of aerogel per batch up to 2 square meters by using the freeze dryer. It's important to note that this production will depend on the desired thickness for the resulting material. The pilot line consists in a semi-industrial freeze dryer, which is a compact unit with casters constructed in a steel stove-enabled cabinet. It has a vial stoppering and spacing device, an isolation valve to condenser, a microsuite software, and a vacuum pump with an exhaust filter. The plant allows to control all the parameters of the freeze drying by using a human-machine interface that provides information about the system elements, outputs alarm information, allows to modify the parameters of the freeze dryer cycle depending on the material which we are working with, all while protecting the system from unauthorized use, and perform some recipe development also depending on the material. As well, a vacuum sensor is installed to control the pressure of the product environment, and the monitoring of the experimental conditions is also possible, allowing to analyze and further develop some better physicochemical materials. As well, the control and improvement of the energy consumption is also possible with this plant. Talking about the sustainability, this plant also allows to work while taking care about the environment throughout all the process. This is achieved by not using expensive reagents, establishing solvent-free processes, using solvent as water, using water as solvent, sorry, with environmentally friendly synthesis routes, and all while reducing the energy consumption of the whole cycle by controlling different parameters of the plant. In fact, this drying technique consumes less energy than the classical supercritical drying. So the main products of this plant are aerogels, which are ultralight materials with very high porosity and very low density. These characteristics gave the aerogel some appropriate properties to be used in several industrial applications, such as the insulation or the construction. The UCLM has developed some different kinds of aerogels, both organic and inorganic, which are shown on the screen. And all of these materials can be reinforced with some silica or nanocarbon, for example, or nanoclays, to improve and enhance their mechanical and fireproof applications. The ones studied in this project are the polyurethane-based ones marked in red on the screen. So regarding the product characterization, we have some different techniques depending on the property that we are measuring. Talking about the morphological and physical characterization, we can determine the density, the infrared spectroscopy, the pore size and distribution, and the micrographies or the internal microstructure of these materials. Some dynamic mechanical analysis are also performed just to check the mechanical behavior of the samples. And finally, the DSC and the TGA are used to determine the thermal behavior of each one of the materials that we are developing. Regarding the project, some low density and high performance thermal insulation biopanels, aerogels, biocomposite panels, sorry, will be developed by the UCLM and installed by Acciona and Ritolls in different mock-ups. This will establish a new solution and an energy efficient solution for the renovation of older structures and the construction of new ones regarding the thermal insulation of exterior walls. Finally, just to mention some of the applications of these aerogels besides the construction, we can talk about the automotive and the aerospatial sectors. The aerogels are working in all of them as thermal insulators. So that's all from my side. Thank you, and thank you, Lutz.
Yeah, thank you for this interesting presentation, and we will continue with Tesman Elliott from Composites Evolution. The floor is yours.
So Composites Evolution's pilot service is the production of thermoset prepreg material. So our expertise lies in the development and upscaling of thermoset prepreg solutions, which are used in fibre-reinforced composite materials. We also have extensive experience in the formulation of thermoset resins for prepreg, and also considerable know-how in the use of natural fibre reinforcements such as flax. We can also offer support in the areas of composite testing, characterization and demonstration as well. So a brief description of our pilot. So to begin with, we can offer formulation assistance. So we can work with very small quantities of a resin, for example 250 grams. We can assess the viability of it for a pre-pregging application. And we can make suitable adjustments to it to achieve certain properties like TG and reactivity as well. And then once we're happy with the resin, we can upscale it to produce prepreg on our pilot prepreg line. So our pilot line is basically a small version of our production line, so it serves as a good proof of concept. And then once we've made the prepreg, we can perform prepreg usability tests like tack and outlife. We can optimize the cure cycle, and we can also produce panels and perform extensive mechanical testing. We can also make small demonstrator parts as well. So on our pilot line, we can make two main products: prepreg, which is where you impregnate resin into a fabric, or we can simply make a resin film. So resin films are typically used for adhesive or surfacing applications. So this is a kind of simple schematic of our pilot line. So we coat the resin onto the bottom release paper. This then goes underneath a blade, which is set to a certain height, depending on what film thickness you need. And then if you're making prepreg material, the fabric will come down, followed by the top release paper. And then the material goes through a couple of heated rollers. The heat from the rollers allows the viscosity of the resin to drop, which allows it to impregnate through the fabric. And it also stages the resin to achieve a nice level of tack so that the material is nice to handle afterwards. And then at the end of the process, the material is wound onto a roll for easy storage. So the performance characteristics of our pilot line then. So we're very flexible in terms of the quantity of material that we produce. So we can work with a single A4 piece up to 1300 mil wide continuous rolls. We're also flexible in the film weight, which will depend on what you're trying to impregnate. We can also film at a variety of different temperatures, up to 80 degrees, which will depend on the viscosity of your resin system. We have a choice of release materials, so different release papers and polythenes, depending on the resin. And we can also achieve adjustable staging and impregnation by changing the temperature and the speed of our line. So from a sustainability point of view, our pilot line is a hot melt prepreg line, as opposed to a solvent-based line. So this means that we have lower VOC emissions and less energy usage as well. And it's also suitable for the evaluation of bio-based resins and natural fibre reinforcements. So examples of where our pilot line has been used within the project. So we've used it for the development and upscaling of bio-epoxy prepreg systems and other bio-based resin systems. And we've also used it for the evaluation of other pilots in the project, such as natural fibre non-woven mats. And then finally, other applications where our prepreg product is used in industry more generally. So basically for anything that requires high performance, lightweight materials, such as automotive, aerospace and sporting goods. Thank you.
Thank you for your presentation. And the next speaker will be Lyudmila Krischuk from Institute for Verbundwerkstoffe in Kaiserslautern. And the floor is yours.
Thank you. Good morning together. My name is Lyudmila Krischuk, and I'm happy to present our team, our pilot line that is located in Institute für Verbundwerkstoffe, Institute for Composite Material in Kaiserslautern. If we speak about organization expertise, of course, firstly we speak about people, and our team, BIOMAT team, is part of competence field, tailored thermosets and biomaterials in our institute. And we cover many, many fields, chemistry, recycling, biomaterials, foam, nanocomposites, compounding, a different type of characterization of process and end product. And we are very strong, not only we, but all team in our institute in research and development of fiber reinforced polymer composites. If you ask me how we can start with you to cooperate, to work together, theoretically and practically you can start with us to work from TRL 1, and we can make development and support you up to TRL 7, 8, and of course development and transfer of developed in development procedure, in this case of in the frame of BIOMAT project, dispersing procedure, of course, included in this service. About our pilot line. Why our pilot line is very good? Because we are very flexible. We have in our pilot line 4 fully independent dispersion models. And we can use these dispersion models in different order. We can combine these models, and the aim of this independency, of this combination, of this flexibility, that we can develop best procedure for effectively dispersing, best stability, and of course with short time and small energy consumption. Also, development is supported with analytical testing during of the process or after process. Some words in details regarding our line, regarding our models. If you speak about first model is 3-roll mill, and this mill is very effective if we speak about preparation of very high fillet system. We can prepare a system with high amount of fillet up to 50%. We have computer-controlled processing. We have monitoring during the dispersing. And what is very important in this case, we can disperse very sensitive fillers such as graphene and carbon nanotubes and not damage during the dispersing. Also, it's very important that in this case, we can prepare storage-stable, high-concentrated batches for production of nanofillet polyol or resin formulations on request. We make, concentrate, and then reduce the amount by dilution with other next steps. Second model is supported with ultrasound, and we can, in this case, disperse also different fillers with lower concentration in comparison with 3-roll millers, but also we can disperse such fillers that, especially those being difficult to disperse. We can disperse this, not only disperse, but simultaneously we can make degassing of the dispersion. This is very important in the case of epoxy composite preparation. This model we can use batch-wise or continuously, and if we speak about batch, we are limited with 2-liter net. Next device is Israel Pilotech plant. This plant is very big wing. If we have big amount of filler, and we can use this function as power suction, and we can make this process dust and loss-free. And this device have different options. We can make wetting, inline mixing, wet milling, dispersing in medium viscosity products. We are very productive in this case with high speeds, and we are also flexible with this device. We can start from 5 kilograms and increase our production up to 70 liters, 70 kilograms of batch. And this Princip rotor starter in general is one of the best for this preparation of dispersion. And last, biggest module in our pilot line is dissolver. And with this dissolver, we make dispersing and mixing by shear forces. And what is important in this case, we have very big volume. We can produce in batch up to 100 kilogram. Next plus in this case, we can make dispersing with vacuum degassing. Also, we can control temperature. It's not a secret. If you have strong shear forces, you have increasing of temperature, and in some cases it can be critically. This device allows to make cooling and heating during the mixing, and we can have stable temperature during the process. We have no other influences and artifacts. And we can use also inline controlling during the mixing process. Regarding analytical devices, I have spoken about inline controlling. We have this very good device from Mettler Probe, and this device allows to make measurement of particle size and count during the mixing process. We can understand the procedure without sampling, and we can make optimization of the mixing, velocity of mixing, maybe increasing or decreasing of temperature during the process. We see that we are not effective with these parameters, and we can at the same time change our parameters for increasing of our effectivity. And this device, it's very also important, is useful for batches to, from 100 milliliter up to 100 liter. We avoid mistake of the device. We use the same device for different volumes, for different batches. And other devices, Lumicizer, this device allows us to control stability of developed dispersant. Of course, it's a very important factor that you want to have stable product. And we should not wait 3 months, half year to determine stability. With this device, we can determine stability at different temperature, from room temperature up to 55 degrees, with increasing of sedimentation, and say in 2 hours, maximal in 3.5 days, that this dispersion is stable or not stable. Main performance. We can produce high-quality dispersions of nanofillers in different polyols and resin. We have inline control. We have optimization of process parameters. And we are very active in sustainability. On the sustainability side, we work with bio-based polyols, resins, additives, and fillers. And of course, with our flexible pilot line, we can send you optimized process with low energy consumption. If you ask where we can use these dispersions, this slide presents you the relevant applications, and in these applications, our team, our institute have experience. We are happy to overcome new challenges together with you. Thank you very much.
Yeah, thank you for your very interesting presentation. And now we have one online contribution from Melodea, Amit Eiger. We can see you already.
I will share the screen.
Yes, you should share your presentation now. And the floor is yours. Yes, now we see your slides, and yeah, exactly.
Yeah. So, hey everyone, my name is Amit and I'm a researcher in Melodea. I will present Melodea and the pilot production of modified CNC. Cellulose nanocrystal, or CNC, are the natural building block of all planets on Earth. They show great performance in various applications and are excellent for production of novel eco-friendly materials. About CNC production, controlled acid hydrolysis of cellulose leads to degradation of the amorphous regions of the cellulose and to the release of the crystals termed CNC. As shown here, produced CNC is in water suspension or gel form. The crystals have a rod-like structure, and when they are dry, they can form very nice transparent film with very interesting properties. Melodea has a pilot production capabilities for CNC located in south of Israel. We use 200 liter and 1600 liter reactors. The plant is fully equipped for purification and dispersion of the CNC. We also have full QC and QA for a process and a product. CNC can be utilized in different applications, such as barrier packing, film and composites, and a variety of other applications. A part of BIOMAT projects, Melodea developed and produced modified CNC. We developed chemical reaction to change the surface of the crystals from hydrophilic to hydrophobic. We have reached a pilot scale production of MCNC in a powder form. The expected production capacity is 1 to 5 kilo per batch. We perform full evaluation of the product. We can develop different modification for different product. MCNC can be utilized as additive in a composite material. Different modification allow compatibility with different systems. MCNC addition can change properties such as mechanical, thermal, and more. In BIOMAT, MCNC is used as an additive for improvement of bio-based polyurethane forms. Thank you very much.
Thank you for your presentation.
Thank you.
And now we will continue with Mariana Ornelas from Senti. And the floor is yours.
Thank you. So good morning, everyone. I'm here today to present you Senti's pilot line that deals with the production of hydrophobic, flame retardant, and antimicrobial biosilicon nanoparticles. So Senti is a private non-profit research center that was founded in 2006. And since then, we have been working in different fields such as nanotechnology, biotechnology, and surface engineering. We have a strong expertise in the development and scale-up of innovative materials, devices, and technologies, and we also have experience on the upgrade and industrialization of emerging technologies. During the work, the years that we have been working with nanotechnology, we have also developed a strong know-how on the valorization of industrial residues and on nanoparticle synthesis and functionalization. So what do we do at Senti's pilot line? Our target is to sustainably use widely available and low-cost feedstocks, such as agro-residues, to extract silica particles and then modify them to impart different properties of interest, such as hydrophobicity, antimicrobial resistance, and flame retardancy. The maximum pilot production amount is on average of approximately 300 grams per batch. So what are the significant infrastructures and technical equipment that we have at Senti? For the extraction of the particles from the agro-industrial residues, and for the functionalization of the particles, we have a 10-liter reactor and also pilot and industrial scale reactors that go up to 100 or 600 liters. And we extract the particles through a high temperature treatment that we can perform on a 200-liter high temperature oven. To recover the particles from the residues, we can use a 6-liter centrifuge as well as a vibratory sieve. The obtained particles are then characterized by infrared spectroscopy, thermal gravimetrical analysis, ultraviolet, visible and near-infrared spectroscopy, and the size and morphology can be assessed by dynamic light scattering or electron microscopy. We also perform test assessment of interest, such as to assess the antimicrobial activity, the water contact angle measurement, and of course the flame retardancy properties. Within BIOMAT, we have been using our particles in the production of different demonstrators that can find application in those areas or those sectors that you can see on the right of the slide in green circles. Specifically, we use hydrophobic particles to prevent water absorption and humidity. The flame retardant particles are used to prevent flame progression, and the antimicrobial particles to prevent rotting, biocorrosion, and the growth of harmful or other causing bacteria. This is it from my side. If you have any questions, I'm more than available. Thank you.
Yeah, thank you for introducing your pilot line. And now we will continue with another pilot line from CNR from Italy. This will be presented by Selena Silvano. Yeah. And yeah.
I'm Serena Silvano from CNR, and in particular from SCITEC, the Institute of Chemical Science and Technology, Giulio Natta. It is located in Milan, and in SCITEC we carry out both basic and applied research in the field of molecular science, such as the chemistry, energy, heritage science, advanced material, green chemistry and sustainability, and the chemistry for life science. We have many active laboratories equipped with modern instruments relevant to the synthesis of molecules and materials and for their characterization. Pilot 8 deals with the functionalization of fillers in suspension, like the crystalline nanocellulose provided by Melodia, or in powder, like the calcinated rice husk silica provided by Senti, with bio-polyol. The functionalization of filler involves mainly in 3 steps. The first one is the filler coupling, which is performed in a 2-neck round bottom flask equipped with reflux condenser under inert atmosphere and under vigorous stirring. The second step is the purification of crude product performed by using a centrifuge or a Soxhlet apparatus. And the third step is the drying of the purified product. As you can notice from this diagram, the use of fillers in suspension requires a third step of freeze drying. The grafting of polyols is between 40 weight% and 60 weight% for a gram of sample for CNC and silica respectively, and the pilot performance goes from 400 to 1 kilos batch and required for a week and 2 persons. And about the sustainability, both the fillers come from new renewable resources, and in particular the functionalization of silica is a solvent-free process. In this slide, I want to show you some facilities present in our institute and use it for the pilot. We have a freeze dryer used for the preparation of cellulose, the centrifuge used for the purification of the crude product, both purchased with BIOMAT fund and installed in SHITEC in 2022, big reactors with capacity up to 10 liters, and the instrument TGA and TIR used for the characterization of the final product. Okay, I'm finished. Okay, thank you for your attention.
Yeah, thank you very much. Yeah. And the next speaker will be Guillem Ferreres from University of Catalonia.
Thanks for the presentation. I'm Guillem Ferreres from University Polytechnical of Catalunya, UPC. And I'm going to present our pilots regarding the nanotransformation and modification of lignocellulosic biomass. UPC has an expertise regarding polymers, biomass modification, nanotransformation that has been validated in a number of European projects, academic publications, and transfer of technology and patents. The services that we are offering within BIOMAT is the modification and nanotransformation of lignocellulosic biomass. We are mainly working with lignin, but we can use other types of lignocellulosic biomass. In the first pilot, in the pilot 9, we can enzymatically functionalize the biomass to introduce phenolic compounds into the biomass. And depending on these compounds, we can obtain a biomass endowed with increased reactivity, antibacterial activity, flame retardant, or UV protection, among other functionalities. In the pilot 10, we nano-transform the biomass applying a ultrasound treatment to obtain biomass nanoparticles that we can use as fillers for polyurethane foams or adhesion promoters or other applications. And in addition, in pilot 10, we can join both processes in order to simultaneously functionalize the biomass and nanotransform them into modified biomass nanoparticles. I will present you now the 2 pilots. The first one, it's pilot 9, and it allows the modification of biomass in mild conditions. We can work up to 10 liters, and we are working now in concentration of biomass between 30 to 60 grams of biomass per liter. Regarding the pilot 10, this is a ultrasound chamber where we recirculate the biomass to apply the treatment. This system is a continuous one that allows the process of up to 100 liters per hour. In addition, both processes are based on water-based reaction. They have no toxic reagents, and the byproducts are derivative of natural products from plant origin. In addition, our facilities are equipped with a high-performance centrifuge and a freeze dryer in order to remove the unbound substrates and to remove all the water from the resulting biomass. In addition, within BIOMAT, we are installing in the following months an inline monitoring system that will allow us to control the process at every stage of the modification. The main products that these pilots produce are phenolated lignin and lignin nanoparticles that here you can see a nano-sized lignin that we can use as fillers for polyurethane foams or promoters for adhesives. Finally, these pilots are really versatile and we can do other things. We can chemically or enzymatically modify other types of biomass, but also polymers and biopolymers. And we can, in the pilot 9, we can nano-transform other materials via self-assembling principle. In the case of pilot 10, we can nano-transform by fragmentation or with ultrasound any biomass or natural or synthetic material that could endow this process. And we also can perform other zoonoenzymatically process that may be relevant for the industry. And thank you for your attention. If anyone has any question.
Yeah, thank you very much. And we will continue with Andrea Meniger from AEP Polymers.
Good morning to everybody here and also to the online community. My name is Andrea Miniger from AP Polymers. And we are specialized in the synthesis of, in BIOMAT, of bio-based polyols. So AP Polymers is an Italian SME founded in 2013. We work in several fields, fiber-reinforced composites, as well polyurethanes, coatings, adhesives. And our expertise is based on two pillars. One is organic chemistry, the other is polymer science. With the first pillar, organic chemistry, we develop new bio-based polymers and the building blocks for several applications. In BIOMAT, I anticipated the biopolyols. With the second one, so polymer science, we validate the new polymers against commercial benchmarks in real formulation, and we also perform the usability assessment of bio-based byproducts, for example, lignin proteins or other fraction from biorefinery operation. We don't go into direct industrial production, so what we sell as a commercial company, as a private company, are recipes and knowledge. So we stop at TRL between 4 to 5, so in the so-called advanced lab scale, but then we can support companies or partners from TRL 6 to TRL 9, so transfer of recipes, technical assistance, assistance also on the regulatory aspects, and in one case also support to the sales force. Just a few pictures from our lab. So we have basically almost everything to characterize from our molecules and polymers from and composites also from the chemical, mechanical, thermal point of view. The service, so I anticipated that in BIOMAT we focus on the production of biopolyols, and we can cover all these steps in the development of new bio-based polyols. First, the design, synthesis, and the characterization of the biopolyols, and we take care of all these aspects listed in the slide. So from the choice of the raw material, which is in some cases really strategic, the freedom to operate, so we don't want to infringe intellectual property belonging to third parties, and then of course cost, process scalability, performance, sustainability, and rich compliance here in Europe. Then we define the technical spec. We started the first upscaling in-house up to 5-liter reactors. We optimize the synthetic protocols, and then we finally transfer the SOP, the standard operating protocol, to the client or the partner. Yeah, our biopolyols we developed in BIOMAT, but they are representative of also other polyols developed in for commercial customer. They can be from plant oils or from other sources like lignin. Can be used both in rigid and flexible forms, of course, different types of polyols. In terms of performance, first of all, the compatibility with other raw materials in the part A of polyurethane systems. Then a wide range of properties like reactivity, OH value, etc. And the third characteristic, I would say, connected with the first one, they can be used also at a high level inside the part A of the formulation. In terms of sustainability, bio-based content up to 88%, so a good contribution to the overall bio-based content, and a replacement of at least 40% within the part A of the system. Thank you very much for your attention.
Thank you very much. And the next speaker is from Fraunhofer, Georg Werner, introducing the Pilot Plant Center.
Ist schon eingeschaltet, einfach. Good afternoon, ladies and gentlemen. My name is Georg Werner. I'm representing today the Pilot Plant Center in Skopje from Fraunhofer Institute. This is a joint of two institutes from Applied Polymer Research and from Institute for Microstructure of Materials and Systems, with staff of 40 employees and annual budget of about 5 million euros. We are located in Saxony-Anhalt, south from Berlin and close to the Leipzig, with very, very long tradition with rubber synthesis. So what we have, what we can make solution polymerization. It means the rubber, heterophase polymerization, rubber and latex, polycondensation, polyesters, polyamides, and so on, and hydrogenation and kneader technology. So this is a little example for 6-liter line, and like this looks in real life. So we have following equipment, 600 quadrat meter flow ground, and on 3 levels, and main reactor between 50 and 1,250 liters main reactors, and 2,400 liters for working up with high quality steel. Safely, we have gas combustion, wastewater, flexible process control system, cooling system from minus 30 degree up to 350 degree, vacuum up to 100 bar reactor, and 20 co-workers. Continual operation is also possible, and it's fully registered by German and European authorities. So we can make scale up from laboratory to pilot scale, and also in opposite direction, we can make also scale down. So if you come to us, it is important that you have the chemistry has already been fixed, and you interested in optimization of technology, and you want scale up. The scaling up and optimization, chemicals, logistic, and so it's up to us. So a little example of our cooperation with BASF. The BASF wanted to synthesize the copolymer of propylene and carbon dioxide. Why? Because it is biodegradable polymer. So you can see this is a little bit tricky because there are two side reactions, and the main reaction is formation of polyether, and it takes place on high temperature. So it is therefore it is very important to control the temperature, and we used here, for this case, our hydrogenation reactor and two reactors for working up in this continuous line. Okay, and you know the temperature is brought not only by heating and reaction enthalpy, but also by stirring. For this case, we had to design our own stirrer system, and a little spoiler, we was very successful in this work, and the BASF came to us other 6 times. So a little bit other example for the scale down. The customer wanted to study the processing of polycondensation, and for this case we had to scale down from 100 to 1. For this case we designed the 10 liters disc reactor, and after the successful studies we have made the scale up to the 100 liter. So thank you very much.
Yeah, thank you very much. And
The next presenter will be Dr. Lutz Hartmann from Fraunhofer Pico.
yeah, thank you for the introduction. Now it's my task to introduce the last of the technical pilot lines before we switch over to a block where we still present what we call horizontal services. But before this, I would like to introduce our setup to chemically decompose bio-based polyurethane composites by making use of microwave irradiation. I am speaking here first for the Fraunhofer Institute for Applied Polymer Research, which has its main location in Golm, close to Potsdam. But more specifically, I belong to the research division for polymeric materials and composites, PICO, which is located here in Wildau, maybe 1 kilometer about away from here. And the key competences of PICO are mainly in the field of fiber-reinforced composite materials with thermosets as the matrix material. I can only strongly recommend to join the guided tour this afternoon, right after the workshop, to get more knowledge in detail about what we are capable to do in this field. Basically, what I would like to mention here is that we are covering the complete value chain, so to say, from monomer, from basic chemistry up to the manufacturing of complete parts or demonstrators or prototypes. And this allows us, of course, to modify at every stage of this chain, to make modifications and to see what will be the effect of such modifications. For this, of course, we need a wide range of different characterization competences, and also it should be mentioned that I mentioned thermosets as matrix material. Then, of course, curing is an important issue, and here, besides the conventional thermal curing, we have several alternative curing methods available, such as the microwave, which will play an important role in the following, but also optical sources like UV or IR light, and also the E-beam are used. And with increasing importance, the issue of recycling or reuse of materials at the end of their life plays an increasingly role in our activities. Now I would like to switch over to the setup of the pilot line, the microwave-assisted split-phase glycolysis. So we start basically here with a reactor which is filled with, below we see in brown, the liquid phase of the recycling agent. This is glycerol in this case. Glycerol has been chosen because it is a byproduct of oil refining processes, and people are really interested of getting rid of this glycerol, so it could be used in a sensible way if it could act as recycling agent in the case of the decomposition of polyurethane foams. In the middle, we see first the progress of reaction. After some hours, we have here a 30-liter reactor. We have installed a stirrer inside the reactor, which is operated by a motor, a pneumatic motor. We have to use it in the environment of the microwave oven. We can flute the reactor with nitrogen as inert gas. And because typically we heat up the recycling agent to its boiling point, we have also a reflux condenser on top of the reactor, just to be able to do the boiling, at the boiling point of the recycling agent. And at the right, we see then the outcome of the split phase glycolysis. So we have an upper phase which is expected to be rich of the polyols, which has been used in the original synthesis of the foams, and we have a bottom phase in which the glycerol, in this case, as the recycling agent, is enriched. We control the progress of reaction by IR spectroscopy and viscosity measurements typically, and especially in the BIOMAT project, this is still, so to say, in preparation, but we would like to combine the microwave-assisted chemical decomposition with an enzymatic pretreatment of the foams. But so far, we have learned only that if such a pretreatment works, it takes very long time, and the effect is rather small. We will see how to solve this problem in the further course of the project. But by IR spectroscopy, we could prove, at least for the upper phase, given here in red, that we can compare this spectrum of the upper phase with a weighted sum of the raw polyols used in the original formulation, and this proves that the upper phase is the polyol-rich one. And also for the bottom phase, if we compare the spectra, we see that the bottom phase and the spectrum of glycerol, they fit pretty well one to each other. Of course, the point why we are doing this is we intend to, maybe we can go back, we intend to be more energy efficient than a standard process. As you can see here, we have now installed one reactor, one 30-liter reactor in the middle segment of the Hephaestus oven. We have still place for installing 2 further reactors, and so if we get such a high degree of filling of the oven chamber, then we could estimate that at the end the energy balance of this microwave assistant process would be better than that of a conventional process. Okay, and at the end, to conclude the presentation, what else could be done by using microwaves? We have, of course, standard applications like tempering, drying, or curing, but also by making use of indirect heating, where we use microwave susceptors to be heated first. We are able to burn clay, for instance, so this means that in such a small kiln, we are able to reach temperatures of 1200 degrees Celsius. And another representative example is the selective sintering of printed conductive lines. They are printed here on a substrate which itself is temperature unstable, but since the microwave, of course, it also should be microwave transparent, but if this is the case, then we are able just to deposit heat only in the conducting lines, and they could be sintered even on such a temperature unstable substrate. That's it from my side. Thank you for your attention. And now, as mentioned before, this was the last presentation for the pilot lines, and now Oscar Brandon from ETG will be the first to present one of the horizontal services developed in BIOMAT.
Thank you. Good morning, everyone. So I will introduce you the digital twin service, which is developed by ITG. First of all, ITG stands for Instituto Tecnológico de Galicia. We are a private non-profit research and development center located in A Coruña, in Spain. And we are recognized as a national technology center by the Ministry of Science of the Government of Spain. Our main areas of knowledge are the ones that are depicted in the right of the slide, and the core expertise that we develop and apply within BIOMAT Project deals with the Industry 4.0. So, what is the BIOMAT DTP platform, the BIOMAT Digital Twin Platform? It is a web-based tool that provides in all the 12 pilot lines that are available in BIOMAT the following features. First, we acquire the data that is measured within each pilot line, and then we extract value from this data. So we then create the models that are embedded within the platform, and these models allow us to run 2 types of analysis, so to speak. So we expect these models to assist the pilot line users in optimizing the process, and also to explore different scenarios in case some of the parameters or even the materials are changed in one of the process lines. And finally, we have the bioproducts smart recommender, that is a catalog that assists users from existing products to explore which ones from BIOMAT may be suitable for your needs. Going into more detail, the platform has 3 main modules. First, as I said before, we have the data acquisition and traceability. So we import the data, visualize it, and also create all the KPIs that are necessary to track the process. And we also provide traceability, which means data labeling across the different batches that are created in the pilot lines when manufacturing. Then we have the digital twin toolbox, which includes the pilot viewer. So we provide a visualization of the data of the processes at the different measuring points. We have also the simulation manager in order to handle off the available models, and the production dashboard to oversee, for example, the KPIs, the control process parameters, and other parameters. And finally, we have the catalog that I mentioned before of all the BIOMAT products defined by their key parameters. So the platform proposes, based on certain search criteria, the BIOMAT substitutes to a commercial products. So that's all from my side. Thank you so much for your attention.
Yeah, thank you. The next speaker is from UNIMIP, Maurizio Gualtieri.
Thank you. My welcome to the companies that are here in presence and online. I will present the service evaluation of nanosafety of my organization, University of Milano Bicocca is a university, and I will present also on behalf of my colleagues. So the UNIB expertise are related to environmental campaigns, exposure evaluation of human exposure, physicochemical and biological characterization of nanoparticles, nanomaterial, and any materials that can be developed with nanocomposites, the human and environmental nanotoxicology, and of course the safety in a safe and sustainable by design approach. We have published a lot of papers with all the technical and scientific approach that we apply. So in the BIOMAT Open Innovation Testbed, what we propose is indeed the evaluation of the nanosafety and toxicity, considering first the nanomaterial release and exposure during the production processes or the use of the new materials, and then the environmental safety and the human safety. What we propose in BIOMAT is to apply this service in a tiers approach. So the first point we propose is to assess the actual release of nanomaterials during production or use of the new nanomaterial, both at an environmental level, maybe using leaching tests. It is to say that a bio-PUR form can be leached to see if the new composites may have the release of some nanoparticle or some materials, and we use analytical and microscopic technique to assess the release. Or we can check the human exposure with monitoring campaigns directly at the site of production or at the site of use of these new composites. And we propose 2 different packs. One that is a light pack, that is just the monitoring of fine and ultrafine particulate matter concentration, and the other that combine this characterization with the respiratory deposition in humans to see if during the use or during the production we can have actually an exposure of workers or person that will live in a place where the new composites will be used. If there is some release, we can associate the relative environmental safety and human safety in a first step with basic mechanism of action. So it's a simplified approach, and we use the fish embryo toxicity test with an aquatic model that is zebrafish to see if there could be if there is a release and effects on a test animal, or we can use human cells to test if there is a release during production or use, if there are some kind of toxicity or some kind of effects in humans, looking at cytotoxicity, inflammation, and genotoxicity. We can then advance our understanding of the effects using a more deep understanding, again with the same approach, but using more precise techniques, maybe looking at developmental neurotoxicity and cytotoxicity of the zebrafish model that you see here, or in human safety, we can use a more precise exposure for lung toxicity or skin toxicity if the contact with this new material is foreseen through the skin. What I would like to underline is that these tiers are not packed together. If a company is interested just in the likelihood of exposure, can select the first tier, and then maybe afterwards check for the other tiers. With this, I've completed the presentation. Thank you again, and that's all.
Yeah, thank you very much. I think now the next speaker is Gabi Weiss from Global Weiss. I think now we will leave the technical and scientific field and will switch over to consulting and financing of SMEs.
Right and left, yeah? Yeah. Okay. I'm talking about helping small companies, SMEs, SMBs, startups, to finance or to raise funding for, in case they are going to work with us, use our technologies, and many of them require some support. So we are going to talk about fundraising. Fundraising is just the title. We are actually helping. It includes, okay, a few words about the organization. We are doing business development, startup mentoring, entrepreneurship, and international marketing and sales. The time is very short, so I'll skip this one. The goals of fundraising are, first of all, guarantee stability and growth. Of course, we talk about lack of funds, reduce financial risks if you don't want to do everything on with your own assets. Add strategic partners and encourage SMEs to participate in the open tender. So in case they are running too short of money, we are there to help them. Fundraising is actually the main activity in fundraising is preparing a pitch deck. A pitch is going to an investor and present the activity, the product, the system that we want to run, and convince him to invest money. It's not an easy task, and that is the main activity: building a clear pitch presentation for the investor. So this pitch is the main activity, and it will include mapping of the market. We have to show him that we know the market, and the market is clear for us. We study the financing opportunities and connect with potential investors. I mean, that's before talking about the pitch. These are the activities that are included in this service. Okay, talking about the pitch deck, as I said, this is the main activity. The pitch deck will include, first of all, the definition of the problem, the need. What are we going to solve? What problem are we going to solve? And then the outline of the solution. How are we going to solve it? Talking about who we are Of course, the investor will never put money in a company he doesn't trust, and showing the market, the analysis of the market, and the strategy. How are we going to attack the market, so-called go-to-market, and the details of the business plan. Then we show him the roadmap. I mean, when are we going to do what in terms of finances, activities, marketing, development, etc. And then build an equity plan, the ownership, and the fundraising plan. How much money, at what time, when, against what equity. A business plan looks like this. This is the bottom line of a business plan, which is a P&L forecast. It shows the revenues, the cost of sales, and the operating expenses, and the company's financial view. How will it look like? I mean, none of us is a prophet, but we must set targets. And there we want to be. And we present it to the investor in order to show what our targets are. Of course, there are many details. Every figure here, behind this figure is a whole concept. And then after we're having this, we will have a cash flow analysis, so we can show him how much money we need at what time. This is what we do with the SME that will adapt and will be willing to work with us. That's it. Thank you.
Thank you very much. And now, just one moment. We have now a presentation provided by Davinia Brocard from Indatec, but she was not able to be present here in person, but so she has provided a video of her presentation.
Hello and welcome to our BIOMAT workshop. My name is Davinia Brocard. I'm a research and application manager at Indatec. We are a part of the Chauvin group. Indatec is a company based in the south of France that provides spectroscopic solutions for different types of applications. So we provide optical solutions that can provide both chemical and physical analyses through non-destructive and non-contact measurements. In our portfolio, we have different types of spectroscopic tools and techniques, amongst which we can note near-infrared spectroscopy, UV visible spectroscopy, and Raman spectroscopy. But we mainly distinguish ourselves from the competitors or from the classical spectroscopic techniques or tools that you may know through the use of multi-point or multi-angle spectroscopy, as we have a patent in spatially resolved spectroscopy, or SRS. So that means that for solid applications, we will measure simultaneously multiple points on the sample, whereas for liquids, this translates itself in simultaneous measurement of multiple angles. So this can be exploited for, in different types of spectroscopic techniques, and these optical solutions can be used for a multitude of matrices in different markets. So most of our customers are in the pharmaceutical or biotechnological field, where they use these type of spectroscopic solutions to measure tablets, powders, capsules, etc., but also more and more liquids, for instance, in lipid suspensions or cell cultures, and also freeze-dried products. But apart from that, the technologies can also be used in other fields, such as the chemical industry, agriculture, food, consumer goods industry, etc., where different types of samples, both liquid or solid, can be inspected with these spectroscopic tools on the path towards Industry 4.0. Within the project, the goal of Indatec will be to establish a spectroscopic inline sensor concept that can be used to monitor and to smart process the upscaled and nano-enabled biopolyurethane pilots. So this means that we will try to develop affordable inline spectroscopy-based monitoring systems that can provide in situ information of the materials on a molecular level. with the aim of gaining product knowledge and also helping to optimize the processes. For this, we will base ourselves on two types of technologies. So on one hand, we have UV visible spectroscopy, which is based on electronic transitions. And on the other hand, there will be near-infrared or NIR spectroscopy, which is a vibrational spectroscopic technique. Spectroscopy as an inline monitoring tool is selected because of its rapid and non-invasive character compared to conventional analytical techniques such as spectrochemistry analyses. Spectroscopy offers the advantage of requiring little to no sample preparation and being a non-destructive technique that can be used either offline or at line, online, and even inline. So through remote measurements, either at very short to very long distances throughout the use of fiber optic connections. The spectroscopic tools that I have talked about are also compatible with many matrices, which is an advantage in a big project like BIOMAT, where we will have a variety of products to inspect with these tools. In all these applications, we will require spectra, and these provide multivariate information about the samples being inspected that can then be analyzed to obtain either chemical and or physical information about the product of interest. And then these spectra can also be analyzed to develop qualitative and or quantitative predictive models, for instance, concerning the critical process parameters or critical quality attributes of the products under inspection. Within the project, we will install 4 spectroscopic sensors by the end of this year at 2 selected pilots. The pilots that have been presented a bit earlier during this workshop. So firstly, we have UPC in Barcelona, where we plan to install a near-infrared spectrometer that can be used for input raw materials characterization and or final product quality control. So this will be a versatile NIR spectrometer that can be used for inspecting any type of solid dosage form. And then on the other hand, we will also have a UV visible system that will be installed within the pilot line I think we will be using a flow-through cell to be able to perform quality control of the lignin dispersions in aqueous media. And then on the other hand, at HSK in Germany, we will also deliver 2 NIR solutions, one for quality control of the formulation and one for final product inspection of the foams. But the idea is that these spectroscopic sensors are also transferable to other pilots and processes upon request, as the multitude of applications within the BIOMAT project can also be resumed in different unit operations that are comparable. So the idea is to offer spectroscopic sensors for all types of applications through these 4 systems. So if this is something that interests you to measure your samples or with spectroscopic techniques, or to apply an inline spectroscopic sensor for your process, do not hesitate to contact us or to apply for our service within the project. Thank you very much. Have a nice day.
Okay, then we are approaching the end. The next speaker is Mr. Abu Salah from Bailan University. It's switched on. You should. Left is forward.
Hi everyone, I am Bilal from Barilan University. Our university is located at the central of Israel. Barilan at the past was participated in the framework programs as a partner or coordinator, and managing approximately between 20 projects. Here at BIOMAT, we are responsible of the characterization of nanomaterial and the products. At our university, we have a wide selection of instruments for characterization. First of all, I will start with the air permeability tester. There, we can to measure the rate of air flow through a known area of sample, and this is depend on the density and the chemical structure of the material. Also, it will be suitable for the filters, clothing, and building structures. The testing area of the instrument will range between 5 and 100 centimeter. And also the standard, it will be able for paper and polymers and fabrics and so on. Another one is the flammability tester. Also, there the sample at the flammability tester will be positioned vertically above a controlled flame, and and will be exposed for a specified period. Then, following that, the flame source will be removed. So, I can summarize that the test of the flame retardant test is or can evaluating the self-extinguishing ability of the material. It could be polymer, plastic, or so on, and it will be as a function of time. Also, we can provide VOC testing. In general, the VOC testing involves using the GCMS analyzer to discover the VOC in the samples of solid or liquid material. After that, or first of all, we need to heat the sample to a specific temperature, and then we can to measure it at the GCMS analyzer. Eventually, also at Parilan, we have characterization techniques like you see here at the list. Thank you.
Thank you very much. And the last, but certainly not least speaker will be Massimo Perucca from Project Hub, speaking about the issue of life cycle analysis and life cycle costs. Here we are.
Thank you, Lutz. So I have 3 minutes, not 5, to one. So I tried to be fast and effective. Thank you for still keeping the attention after this long morning, very interesting, intensive. So Project Hub is a company with a small medium enterprise with 10 employees. We are developing business plan development, life cycle costing, social life cycle assessment, IP management. We propose to support, we offer to support companies involved in BIOMAT and also customers accessing through the SEP business plans related to the specific implementation of innovative solutions. We go through market analysis, competitive analysis, value proposition, and also we leverage the sustainability value proposition within the BIOMAT solutions, address BIOMAT solutions. We consider the whole life cycle assessment from cradle to cradle, when possible to recycle, but we have very promising solutions within BIOMAT for recycling of bio-based materials. So this is cradle to cradle assessment, and we perform analysis according to the ISO standards 14040 and 44 in order to provide also results and reports which are compliant with these standards, and also in the end can be used for certifications, including also carbon footprint for referring to the ISO standard 14067. I don't enter into details. We are able to provide different components to the environmental impacts, so measuring different effects, and our aim is to work on a quantitative based approach, which is able to allows us to, and also companies, to compare solutions in a eco-design perspective, but also having a specific profile of their results, their final optimized results. Want to also say something about life cycle costing, which is carried out according to the LCA framework. This is not a standardized process, because only building and construction has standardized process for the LCA, a methodology for the LCC, sorry. But of course, in order to obtain the final cost of production of new solutions, there is a big part to be analyzed beyond that, and operating cost, OPEX, CAPEX, investment, and also infrastructure cost allocation. So we were working also considering the value stream, which is an innovative approach that was 20 years ago applied first in petrochemical industry, and then now is getting more and more interested in different industrial sectors. So one more thing related to this social life cycle assessment. So it's possible also to determine the impacts of material selection, logistics, origin of raw materials, and the way we produce, including the energy sources, in terms of social impacts according to the top-down approach. And this will be possible through the use of databases that report statistics on different geographical area all over the globe. And we have different impacts, of course, characterization factors and impact categories. There are several stakeholders involved in this analysis, and we can provide even here quantitative approach. So this will allow us to improve these social impacts on the solutions. I don't want to enter into detail, we are of course available also to provide RPR assessments, so patent search and analysis of the condition of freedom to operate when addressing new solutions. It is very important in order to avoid making efforts in terms of human resources and economic burden to then have some solutions which are not exploitable. So we are working on these topics since 20 years. So it's when ecology and green transition was not the keywords. So we were already believing in that. We believe that this is the right way to go, being quantitative and trying to optimize as best according to the best available solutions. And BIOMAT is offering, I think, most of them for the near future. Thank you for attention, and thank you for participation.
Yeah, thank you very much. I think we have now reached the end, at least of the presentations, of all presentations. I would like to thank all the speakers present or online once again for their contribution. For the persons here, we would continue with the lunch, but first Christian Dreyer would like to do some concluding remarks.
Yeah, thank you very much for the attention of the audience, online and offline, or in presence, no, not to be online. Yeah, I think that was a very interesting workshop, and I already saw that you made also some be or multilateral new contacts here. So it seems the workshop seems to work. These who are in presence here are invited after lunch to go and see our research division. We will split us into approximately or probably 2 groups. One I will guide, the other will be guided by Dr. Köhler as a current planning. And we're making so circa 1 hour lunch break, so that we meet, let's say, 5 minutes before 2 in front of the Mensa. My colleagues will guide you to the Mensa. Don't forget the vouchers, otherwise you have to pay the menu. The vouchers are on the table here at the end of the room. And yeah, hopefully you enjoy the lunch. Feel free to have further conversations. Thank you to again also to the people attending outside. Especially also those who joined in a very short term. Yeah, if there are any questions, don't hesitate to contact Dr. Hartmann or myself, or write an email to the corresponding persons who are presented. So thank you very much, and see you. At least the most of you soon in the Mensa and at BICO.
Yeah, maybe a very last remark concerning the name badges. Those who are leaving now should put them into the box on the table there, and also please sign the attendees lists also on the table in the background. So thank you very much. Also to the online speakers, we thank you for